In this video, we'll talk about factoring binomials involving perfect squares. We might run into one trinomial that we're going to talk about as well. So when we say perfect squares or perfect cubes, obviously a perfect square is a number that can be broken down into a factor times itself. Perfect cubes can be broken down into a factor times itself again. So just a quick reminder, 1, 4, 9, 16, 25. Perfect cubes would be 1, 2 is 8, 27, 64, on and on. When we're talking perfect squares, let's start with a difference of squares. Sometimes people write it as the difference of two squares or the difference of perfect squares. It's the difference of squares, however you want to write it. The formula that we start with is if they gave me a problem that had a squared, which is just a perfect square, minus, because difference, b squared. The pattern for this is that you square root both pieces, and this one gives me a, and this one gives me b. And we use those two things once and again. In one of those, we have a plus, and in the other, we have a minus. It doesn't really matter whether the minus is in the first one or the second one. What does matter is that your A and B are in the same order as the problem. So an example of this that'll show you a little more than just A and B, let's see. If we had 9x squared minus 25y squared, we would square root here and get 3x, square root here and get 5y. Those are now our A and B. So we're going to do 3x plus 5y and 3x minus 5y. And that would be the factors. If I multiplied those back together by FOIL or box method, then I would get 9x squared minus 25y squared. Just a note, because this will come up later on in math, these are also called conjugate pairs, where you kept the same terms, 3x, 3x, 5y, 5y, but the signs are different. Let's do one more just to help us out with a couple of other little topics that are involved in this. Let's say we had, let's make this x plus 2 parentheses squared minus 16y to the 10th. So that looks a little intimidating compared to what we were doing. However, really shouldn't be that bad. If I square root x plus 2 squared, since the entire thing was squared, they cancel and I get just x plus 2. When I square root 16y to the 10th, the square root of 16 is 4. We already know that. How do you square root a variable with a power that's not just 2? Since this little index is 2, you divide by that. So that would be y to the 5th. So my answer is going to be parentheses x plus 2 plus 4y to the 5th times x plus 2 minus 4y to the 5th. All right, so that's difference of squares. Let's talk sum of squares. If I have a squared plus b squared, so most of us, our first instinct would be to square root these and figure out a way to do pretty much what we just did with the difference of squares. Unfortunately, it does not work that way. This is prime, unless you can take out a GCF, which in my case I cannot. So even if I gave you something that looks like a beautiful, easy square problem, like let's say we had 36x squared plus 49. And you really wanted to square root this and get 6x and square root this and get 7 and do your plus and your minus. It doesn't work. This is prime. Now, when we talk about cubes, things start to go a little sideways for some of us, but it's not that bad. I promise you can do this. I have faith in all of us. So when we talk about cubes, Notice I didn't say the sum or difference. It works for both. So we're going to start with a cubed plus or minus b cubed. Notice that I put a plus or minus here. That means we're going to do a formula, one that works for plus and one that works for minus. They just look the same. I'll explain it as we go. Your first step is still going to be to cube root your pieces here. So if I cube root a to the third, remember a cube root has a little 3 there, I get a. And if I cube root b to the third, I get b. Now, there's a pattern. When you do cubes, you have a binomial first and then a trinomial second. So that means I'm going to have 2 things here and then 1, 2, 3 things here. All right? When you fill them in using your a and b that you got from your cube roots, it goes a, b, then you square a and b on the outsides of the trinomial and you multiply a and b together on the middle. Okay? Regardless of what they were, that's what you do. And you're not worried about your signs yet. Now, some people memorize the order of the signs, which is just fine. However, the way that I learned it and the way that I've taught it that seems to work well, S, O, A, P. Use SOAP. Same sign as the problem, opposite sign from the problem, and always positive. I just wrote always plus. Let's try again. Same thing, but always positive. So since this was a plus, the first time it would be same, opposite, always positive. If we did the minus down here, it would be same, opposite, always positive. So let's get a couple of examples going. Let's start simple with x to the third minus 64. X to the third minus 64. If you want to take a second and pause this and try it on your own first, you can. I'm going to go ahead. Cube root both pieces. So the cube root of x to the third is x. The cube root of 64 is 4. X, 4. And then over here I have x squared and 4 squared. You guys go ahead and do the math when you put it in. 4 squared is 16. And in the middle I multiply 4 times x. My sign was a minus, so same, opposite, always positive. This is the answer. If you have done this correctly, this trinomial does not break down anymore. That is it for that trinomial. It does not do any more factoring. That is the answer. Now, I will remind you, on any of these, you should always search for a GCF before you start. Otherwise, you could end up with all kinds of craziness. Let's do another example. Let's do 8x to the third plus 27y to the 9. Again, if you would like to pause and work it out yourself, that is completely up to you. The cube root of 8x to the third is 2x. The cube root of 27y to the 9, well, the cube root of 27 is 3. And remember what we did earlier with the square root. You took this little index and you divide by it here. So this would be y to the third. So when I set up my answer, binomial, trinomial, I have 2x and 3y to the third. Now, I'm going to take my time with this next part because some people struggle sometimes. When I put my 2x in here and square it, that means I square both parts. 2 squared is 4, x squared is x squared. Down here, 3y to the third squared. Now this one, this is where some folks get a little confused. It shouldn't be too bad though. 3 squared is 9. Think real hard about this. Exponent rules say that when I have a 2 outside and a 3 inside, I multiply those. Y to the 6. And in the middle, when I multiply my 2x and my 3y to the third, I get 6x y to the third. Sign, I had a plus here. My words didn't want to come out. I keep the same sign, opposite sign, always positive. And there we have it, you guys. That's how you do your perfect squares and your perfect cubes. Good luck.